here. If we take the section, we see that we are having level 1, level 2, and level 3 up there. If we want to construct our roof, you will build a slab, and then if you want to extend the parapets in order to be above the, or extend the wall in order to be above the slab, maybe by 1 meter or something, I think this is easy to be done. Let's just go through what we need to have. If you go to the level that you want to construct your slab in, this is what you would see if I have my level 3 as my slab or my roof plan. Go back here to roof, floor plan, level 1. If I look at the section, I see that this is my level 3 and the walls are coming and stopping at it. You still can adjust that. If I go to level 1 again and pick the walls, you still can pick whatever walls existed in your building. You can pick them, or you pick similar if you have given these external walls identified or different identity compared to the other. You can just pick this by picking one and then select similar. But here it's level 1 up to level 3, so that I can make an offset from level 3 by making 1 meters for the parapet and then apply. And when I go to level 3, I will see this in my plan. Now the other thing is that you can, instead of doing this, you can create a level for the parapet here and name it maybe level 4 or something, and then bind your walls to level 4 rather than make an offset from that. But that is representing my wall, and I still here I don't have any slab here. That's why I'm seeing it without the slab. One of the things that we need to also discuss is the relation between the wall and the slab. We discussed this initially, and we said that it might have. Just move this from the side here. We said it might have this connection or this relation. Let's just make it fine. What I have here is this slab, and I'm having my wall configured like that, so that I make the end of the slab connected to the edge of the wall like this. And that is the normal or traditional construction method that we are doing here by building our columns and building our beams, and then make the slab rest on the columns and beams that are called spandrel beams, which is outside the boundary or the exterior. But as we said, those are making thermal bridge because they are carrying the temperature from the atmosphere to the interior. Here, the slab is stopping here, and it's not continuous up to the edge of the building. Of course, if you extend your slab to this line, what you will see in the elevation, you will see, as I showed you before, you will see strips of these concrete elements that are shown as a strip in your elevation, which will be looking ugly unless it's designed so that we hit the slab at this level, so that we have some sort of cladding or anything here is continuous to cover the break. So that the structural element of the wall, which is represented by this, is aligned with the slab in order to hide everything inside and keep that. But it's still going to make a little bit of thermal bridging because it will carry whatever force, whatever thermal stresses with it inside the space. And you'll see that if you come here and look, if this is the exterior and this is the interior, what's going to happen is that if the heat strikes the building, it will be resisted by the skin of the building. And this skin has to be continuous layer by layer in order to resist any passage of heat inside the space. But if it comes here and penetrates that space, this material, it comes to the concrete here and will be propagated easily inside the space because that material is different than this material up on top of it. So that imagine you're having a clay brick on here and concrete that is listed on the concrete here. So once the heat gets inside here, it will face lots of problems traveling into the clay, but it will travel very easily into the concrete. And then once it travels into the concrete, this slab will rise in temperature, and then it will serve as an oven or fireplace. It will emit the heat into the building easily. So that is the function of it. Have your building from the ground up to here, going all the way like this, like that, covered with the skin, and then you make the exposures as minimal. You don't want to have these blades outside the building. Of course, architecturally, you can do it to serve some purposes, but I'm saying that whenever you do something like this, like our beams and columns in our building, they're coming out of the space. They're going into outside. These are heat carrier. They can carry heat easily into the building. So this is something we need to think about. In the West, in some buildings, what they do is that they completely put their slab inside the parapet here. Inside the wall, or sometimes make a space between the wall and the slab in order to make those completely thermally separated from each other, so that this skin with the layers that it does have will behave the same even in any spot regarding it. Let's go to level 3 and then draw it, and let's see what I'm talking about. So this is my wall. Just to give it here, if we did this as okay, detail is fine. That is my basic wall. Let's go into that. Okay. Right. I would go. Let's go here, level 2, and lock that. So I have this in level 2. I have this as a column, and I have my wall, and the column is flushed or is aligned with the edge of the structure wall. So if this is the main structure of the wall, it's aligned with it like that. So you have the option. We draw the outer slab at this edge. We can draw it to be inside. We can draw the slab to be at this edge here. If we do it this way, the relation between the wall and the slab will be like as if they are tangent to each other, not one resting on each other. So that we give a chance to the wall to be continuous, and the slab is attached to it from the side. Rather than every single thing has advantage and disadvantage. Let me draft this here. So this is our slab. Suppose this is the two edges of the building, and I build my. Let me continue that. Let me do the here. We have at the end edge 2 beams like this. I'm doing this with the mouse. I have 2 beams that surround the edge of the building, and on that we will build our walls. So this is one wall, and you come at here and do another wall. Right? This is the tradition. This is what we do in our buildings like this. And we can come at the end and make a layer of painting or a layer of cladding on the surface here, so that on the elevation this will show up as one element. And the problem, as I said, that once the heat strikes the building, those elements will transfer the heat very easily inside the space. That is the disadvantage. The advantage, as Ahmed says, is going to be stronger to have it this way. The other option is to come and make the wall separated from the slab, and of course you provide some mechanical bonding here and there in order to attach this to that, and you have your layers. So let's now look at the heat. Now your heat will strike the building and will come to here layer by layer, will be resisted by these layers equally here and there and there. Whereas if it comes here, once it hit here, it will, because of the concrete nature, it will transfer quickly into the space. Whereas here, if this is from insulation or something, certain material or clay that resists the temperature, it will take lots of time till it comes to the outside here, to the inside here. So this will rise up quickly. It wants to imbalance with the space, with the indoor here. So what's going to happen is that it will emit heat easily into the space. Up and down. It will rise up the temperature inside the space. Here, it's not the case. Here, we resist because of this. So that when it gets cold and you're wearing a coat, what do? You zip it, right? You zip the coat because you zip your coat because your chest is exposed to the temperature and you want to get warmer, so that you want to wrap up your whole body with this coat. And that is one of the things, because your chest is going to provide a weaker cooling because it's exposed directly to the outside of the atmosphere, and it will absorb the cold very quickly. So that you want to just make sure that your whole thing is coated. So that the concept here is to have our building like this, skin by skin, like as a skin, different layers, resisting the environment. like this, and we have the activity inside. So that whenever we want to minimize the element or the layers that goes from inside to the outside like that, we want to keep layers in front of the resistor thermal pressure layer by layer in order for it to work efficiently. While we're doing this construction, we have advantage and disadvantage for sure. And of course, this, if it's not done properly, is going to be weaker, especially if we go high rise, if we go 6, 7, 8 floors. 2, 3 floors is not an issue, but for this one, it's yes, it's a stronger, but it does have lots of problems. Given not only this, the thermal problems, it's going to be also affected by the expansion, the thermal expansion. Whenever you put two materials side by side and they are exposed to the same temperature and same heat, they will behave differently. One of it might expand or contract different than the other, and this will make lots of cracks. You go into buildings and walk there, and you see that some of the facade is filled of cracks. You see like cracks going like this and cracks going like that inside into or in front of the or on the surface of the building. Why? Because you are applying different materials that do have different expansion. And this is, by the way, you can notice this sometimes even in the bathrooms, in the interiors. Whenever you have pipelines that goes into a certain place, and these pipelines are providing cold and hot water, what's going to happen for the tiles in front of it? Sometimes they crack, they break. You see that there are lots of breaks happening in the tiles here, and that is because you are providing two different conditions behind these. So that these are the details that you really need to look at. This is a detail, but this thing is critical to understand, to see what is the arrangement here and how you propose to overcome the problem. Okay, coming back to what we are having, so that's what I'm saying, that you can have your slab completely embedded or constructed after the wall or within the wall like this. But if you choose to make it like that, always remember to, unless you want to expose it without, always might struggle with. If they are attached top to base to the slab, you have to make them detach this to that, so that we can go on. Because I have here two constraints. I put two constraints. One of the constraint is to make it from level 1 to level 3 or level 4. The other constraint is I make this slab, this wall capped with a slab here because I attach them. If you make this same mistake and you didn't find it working, you have to detach them from each other. So that by now I want to make this up to level 4 and apply, because this of course will have a head here because of the people access to the roof. And of course you have to build your parapet or build your another slab here. So the stairs should be going up to this level, and the shaft would work. So the shaft, as you will see it, is running just here. If we expand it, I don't know if I take the right shaft or not. Let's go to the level section and figure this out. Oh, I didn't build the shaft actually because that was in the old file. I don't know where the file is. But the shaft is in here. We still can make it. You can pick the edge of your slab and then make that. If you go to yes here, okay, this is not what we're looking for. Okay, the shaft is sitting up to here. You can adjust it, and then by that it will cut into the slab. You can still make two slabs separate, but I prefer to do this way because that is really one slab, and then it does have a hole in it, so that you can make it this way. Of course, do not expand this up to infinity or up above the other level, because you have here a slab that should show up as your other slab, so that you can go to level 4. Now when we take this, also we have to do the same trick, whether we are we want to go above the level by 1 meter in order to account for the habit, so that we can say yes, make this, so that once we build our slab, it's going to be in here. So what you can do is go to level 4. Now we have level 4 in there. You can build your slab, and that is doable by going into structure, and we make our floor and build it. Of course, account for the layers. Do not forget these layers that we introduced. Do not attach. So that if I go here, I'll see my slab built for me. I don't know if this would work. Okay, this is also one of the handy tools that like property match or match property. So that would work this way. I'm giving you this in order for you to tell me at the end how the roof will look like. Because I'm cutting into that, it gives me those in thicker lines, because that everything else is shown as an elevation. If I take that one and I make it go to level 4, it's going to be bold because I'm now cutting through it like this. But that is what we need to see. This is the products, and then the room of the roof or the stairs room is cut through, so that's why it looks bold like that. And of course, you know that this has to have a wall here and the stairs as well. So that these are already explained, so that no need to go through this again. In here, you will still have to account for the stairs, either by building your wall, or I think the other feature that you can do is that take this wall and make it also attached to level 4, if I still remember, and make an offset one attached to level 4. Apply. So this one now is higher than the others. So you can build a small wall on top of it like this and make the base of it level 3 up to level 4, or build it as one wall and come to that elevation. You have here it's higher than the others. So you can edit the profile of it. You can edit the profile of the wall by coming in here and take this, take that. I'm just doing this on rush, but you have to make your lines correct. You have to pick the right lines in order to. I'm just giving you here what you need to do. And by taking this, you can trim or drag. And also that one, drag it like here. This one, you drag it in here. Of course, some of you, if you are aware of this, I think you are falling asleep now from me. But that is how it looks like. Now the thing is that if you use a line here, but if you do two separate walls, you will see a line here in the elevation, because it deals with them as if they are two different. You can still try to attach them to each other by picking one and selecting this joint. With the other one, it will work, hopefully, if they are sharing the same material. But that is another trick to how to do it. So if you go to level 4, you will see that this is shown as an elevation. And see, that is what I'm afraid of, because I did not set the intervals. And anyway, right, let's give it a number now. Yes, no, let's give it another name here. 122. So the options here, it tells you automatically save and then give you. Now the idea of saving different versions sometimes is nice, because if you did something, if you did a mistake and you want to revert back to the original file, you still have it with you. If you are confident, you can just cancel this option and then just save to one file. It says this is something can be done. When I trim the wall, it seems like I cut into below the slab, so that's why my wall here is not trimmed, is not shown in here. So that you have to go back into the elevation, and this is what I'm saying. This edge has to be actually with the parapet. It's not like I cut it wrong. It has to be with the parapet in order for you to see it. So that let's do this. If I take that, I can go up here, and I pick this, I go up there, and then I want to make sure that okay, because lines, yes, continue. I have to pick that and drag it here, and take this and drag it here, and hit OK. So this is it. If you go to level 4, you will see it's shown. Level 3, it's shown in it like that. Right. What else we want to see? We want to see, of course, the walls, the windows, the doors that you cut through, if there is, and of course the parapet, if it's still high in some page of the building, it has to be as if you're cutting through it. And the most important thing that we want to talk about is the slopes in that roof. And last time, one of the times that we met, we talked about making the slope into the slab. And if you pick just the slab and you go into edit the type, you will see in the structure here. Of course, this was generic. I didn't do anything in it. I just have concrete cast in place. This is 20 centimeters. Structure materials is variable or not. That is the key. Do we make and then we have membrane and then we have finish, concrete, sand, cement. Let's give this a second and talk about it. Where do you understand the concept? How to make this variable? If we make it variable, what's going to happen is that once we make slope in the roof, it will cut into or reshape the variable layer for us. So that one be carefully working with that. Which are to make any adjustment in the cast layer here, and the other layers of the moisture and insulation is going to be hard. Once you adjust the layer here that hold the tiles and make the slopes in it, everything else on top of it will be sloped. So that the tiles, you can adjust their directions and their slope by adjusting the layer below that. And this layer, by the way, is not 2 centimeters. It can get up to maybe 10 centimeters in order to account for the slopes that you have. Now, the other thing that we have to be careful about is that by coming into the space, into the and select a point and make this point going deep. If you are making a point going deeper than the thickness of the layer, the software will give you some problems, because you make sure that whatever you create in the layer that is variable, whatever slope you created, you want to make sure that the least point in it is not more than the thickness of that layer. I hope this is clear. So you have to in your structure pick which layer should be variable. And that is, as we said, as Musa says, it has to be in the layers below. And of course, like, so this is my slab. When you go to it, you have to adjust your layer to accommodate for the insulation, the insulation, the insulation, all of these layers, the protection, the grain, everything else has to be adjusted here and then put. And then the layer that follows the finish should be a layer that do have the variable in it only. And once you do the variable in it, you can adjust it using the. But let's for now, I will do this as if it's 0.1. As I said, the finish is not the one that you make it variable. The layer below the finish is the one that you make it variable. It's sand, or it's not supposed to be sand. It's supposed to be from paste, because you mix this with cement in order to account for the water. So I have my slab, and of course you remember that this slab was I created here because the white area tells me here that this is separated like that, but that is not also the case with us. Let's just hit the boundary and push this. I want to just delete that. Just leave it like this. Edit boundary. Okay, doesn't matter now. Okay. So what you want to do is that you want to create a slope in your slab. Let me delete that. How is this done? By creating the slope. Now, usually you don't want to make the water travel more than 14 meters without having with one slope. More than 14 meters is going to be hard, because at the same time you want to maintain a nice slope for people to occupy the space if it's occupiable. So that you don't want to have a slope line that is more than 14 meters. But we can divide our slab into different regions, different zones, and make the runoff of the water towards one of the gutters that are there. Like one of the things also that we want to look at is that when you drive the water off your space, you don't want the water to come outside the walls and hit the wall. And we see this most of the time. We see that. Let me draft this here rather than going to the people comes here and make a gutter like this, and make another gutter in here. Or a pipe actually like this, and make the water run off and then leave and then spill all over the space below. And that is not the correct way to do it actually. You don't want to have something like this into outside or outside the building, because eventually, even if it doesn't hurt your building, or if it doesn't hurt the outside, it will hurt your building, because the water will also accumulate on the walls, and then it will mark on the walls as if like this was rain or runoff water footprint. So if you want to avoid this, you want to make your slopes towards the inside or towards some ducts that is developed in your building. If you have wet area here, for instance, you want to make your slope towards the inside, not towards the outside or close to the edges. You want to make it someplace here. Like we can pick our roof again, and then we can add points and add split lines. These split lines to divide our space. If I have such a space like this, it's going to be hard to have this space open to the other space by one. So that I can separate, and I can come pick this and add a split line. By adding a split line, I can adjust zones. So if I define the zone here, I might come and define another zone here. So these are 3 zones now I defined in my slab, my roof, 1, 2, and 3. But I need also to define where the collecting point should be. So that if I come here and make a point here, and come there and make a point here, and maybe make another point here. These are the 3 points I can define by picking those, and it asks me how far I want to go. So that if I give my negative point, I remember that I put 0.1 for my thickness. Let's make this as maybe 0.05. You see that it's starting to create something like this to me. But I have a problem here, because it sees that this is as if it's one slab for me. Let's continue those and then see how can we adjust for those. 0.05. And come here. And hit OK. So once I do this, I know that I have created a slope in my tiles and my substrate towards this point and towards this point and towards this point, so that I know that this is by itself contains the space here, and this by itself contains the space here, and this by itself contains the space here. You still can adjust this by having one point here and have the whole space here drain to it like that, and this one maybe drain to here as well, so that you are having it. But the problem is, if you do have obstacles like this room in the roof, you cannot have one. It's going to be hard, because the water will run off like this and then stick or get stuck to the premises of the room here. So that is something that you have to pay attention to. Yes, spot slope. This one. If you come to it and then have it here, it's going to tell you that what is the slope. So this tells you that it's 11 over 1,000. That is the slope. If you come here, 16 over 1,000, 14 over 1,000, and here there's no slope. Here it's 9 over 1,000. Because if the distance increases, that means you are going into a less steeper one. So that this is what you need to have, and you have to write the tag of this slope in here. I think you still can edit the type rather than have it as a fraction. You can have it, I think, as a decimal. Text yes, this one, unit 4. You can come here, and this is for each 1,000 millimeters. The rise. What is it? Or you can put it as a ratio. Ratio to 1, and then OK, apply. OK, and then go here. Here is the slope is almost 0, because we did not define the resolution. So we can go here. And because of this, if the ratio is too small, it's not going to show, so that you can adjust it here to that, or you can adjust the rounding in here. But anyway, this is what needs to be done. You can adjust it from these elements, and it will show you the slope of these lines. But the critical thing for us is to make the lines here adequately done. You don't want to make something that's too steep, so that normally it's going to be like this. If you are going maybe 10 meters, you want to make a reasonable slope. Maybe how much? This can be grabbed from some standards, but you pay attention. This is not a ramp. You are doing a slope into a space, into a floor that can be usable. So that this is why we need to be reasonable in adjusting our slopes. And also you need to put tiles in here to mark this whenever you cut it, and the space is shown as if it's a material. So that what you want to also is to come to the floor. And once you edit it and you can do this by the two ways that we said before. You can come to the finish here, add another layer and make tiles. And by making tiles and adjusting the spacing and hatching of it, if it's shown as an elevation, it will show up in here. Or you can paint, similar to what we did before here. You can take the space and paint it using the hatch that you want to see. But pay attention also to, once you do this, you want to make sure your hatch is not, I wanted it to be drafted in order not to have the, let me just see